we're going to do 6-1 in this order, just because it makes a little bit more sense. You'll see when we put it all together, because there's some places where you have to use that U substitution that we learned about in the last lesson. Okay, so slope fields. So
such a warm.
I know. I'm gonna knock the blue marker off the You're not amused.
I am completely not amused. Okay. So, differential equations. Basically, we've worked with differential equations before. Any equation involving a derivative is a differential equation. So here is our first example. Let's say we start with secant squared x plus 2x plus 5. Now this is going to look very similar to things that we've already done. It's just, I'm going to take you step by step through the process. So
it's not that hard.
This first part will not be difficult at all, because it's basically repeating the process of just finding the antiderivative, essentially working backwards.
Would you be like Ms. Campbell and realize that we're not a smart class?
So, I'm not going to really address that last question because I deleted it, or hopefully most of it. But let's just say that I'm not changing any of the curriculum will stay as is.
Any scientific field?
So first thing I'm going to do is multiply. It's as if you're going to multiply dx to both sides, but we want to put dx at the end. Okay?
Hey, 1 second. I'm ready. Hi, Maya.
Then we want to take the integral of both sides.
Wait.
Okay, so one of the things that we learned about in the last lesson, or even from the last chapter, the squiggly line, the integral sign has to go with a dy or a dx or a du, okay? When we integrate, it eliminates both parts. Now, how do we integrate dy? Well, imagine that there's a 1 here. So what do you think? What's the antiderivative of 1 dy? Well, what's the variable here? It's just y. It's 1y. Guys, let me just explain. If I had the integral of dx, I would get x. If I would have the integral of dw, I would get w.
So we remove the d from the equation.
Basically what happens is these go together, and no, we're taking the antiderivative of 1 would be y to the first. Think of this as y to the 0 power is really here. So if you had y to the 0 and you applied the power rule, it would become what? It would be y to the first over 1.
Yeah.
Okay, now let's do the right side. What's the antiderivative of secant squared?
Yeah.
So it's going to be tangent of x plus, then you're going to get 2x squared over 2. So the 2's are going to cancel, so it just becomes x squared plus 5x. And then there's something we put at the end. C. Now, right here it says find all functions y that satisfy dy dx equals secant squared x plus 2x plus 5. This is how you solve a differential equation. We started with the derivative and we worked backwards to find the original. Right? This is the derivative. This is the solution. Again, it's kind of like, if you will, that's the original. Okay, so let's find the general solution. Anytime you have a general solution, you're going to have a plus c in your answer. what were the steps that we did? We first we have to rewrite it so that it's a dy equals secant x tangent x minus e to the x, and then move the dx over. Now what? Okay, second step, we want to get rid of, basically what you want to do is you want to cancel out the dy and the dx. The only way you can cancel out a dy and a dx is to do the integral sign.
So can you can integral sign both sides?
It's like that, you're basically balancing the equation. Okay, so we move the dx to the other side, but then we want to cancel these, so whatever you do to one side, you have to do to the other. What do we get on the left side? It's going to be y. If you don't remember, this is secant x.
If you want to see, you gotta get.
What's the integral of e to the x? E to the x. And then we need one more thing, and that's the plus c. How do you tell if you did the correct answer? You could do the derivative of this.
Wait, I don't get how secant x tan x became secant regular.
Well, the derivative of secant x is secant x tangent x. You may or may not remember that formula, but that's what it is. So when you work backwards, that's what you get. Okay.
This is hard.
This one, yeah, they get a little more challenging. First one here. I would write maybe using powers, right?
This one's not that bad.
Okay, so when we take the antiderivative of both sides, what do we get?
You get y.
Okay, so y equals.
Y equals.
Now this is the one exception to the power rule where it
the absolute
doesn't work.
value of x.
This is ln of absolute value of x, and then let's apply it here. So this is going to be minus,
X minus 1 over negative 1.
so it's x to the negative 1 over negative 1, and then plus c. Now notice that in the beginning I gave you a domain that says x is greater than 0. If x is greater than 0, do we need the absolute value signs? No, we don't need it, because just remember that that's one of the reasons we have it in the first place. So it's going to be ln of x, and then it's going to become plus 1 over x plus c. Questions? So far, so good. I must say I actually like differential equations because it's like step by step. It's just move the dx over, integrate both sides, put the plus c, and you're done.
Integration. Just like the South in Manchester.
Okay.
I'm very good. Like, I'm bringing in topics that have to do with many subjects I'm learning about. Like right now I'm learning about that in Gov. That shows that I'm a very attentive and good student.
Absolutely. Okay, so move the dt over.
So that's just the first step.
Yeah, that's just, oh, whoops.
What was that?
I opened up a window I didn't mean to. Okay. Now, this one, yeah, now notice this one has a composition of functions. Okay, so this one has to use the u substitution. So over here on the side,
When these things all combine and it starts out simple.
what would you use, what would you make u equal to?
Sun T.
Thank you,
Thanks,
Carmel.
Andrew. Thanks.
So du
One moment to shine, you just took it away.
is cosine of t
I'm really
dt.
scared how Carmel's voice got a lot deeper to answer that question. Yeah, I don't know, man.
Just stop talking on the screencast because then I listen to them and I hate the way I sound. So I'm gonna shut up.
Okay, so I want to rewrite this. Remember, with the u substitution, it's we want to eliminate all the other variables and we want to have just u involved. Now, cosine of t, even though it's over here, we could replace cosine of t and dt with the du. So I'll put du at the end.
So it's e to the u to u.
Okay, what about cosine now? Or I'm sorry, e to the sine would be e to the u. Let me pause there. Questions on why I rewrote it that way.
We're just combining one thing I never understood to begin with another.
Now you integrate.
Guys, questions? We're okay with this?
Not really, but let's just keep going.
Okay.
It's second semester.
I'll wait till the day before the test.
So it's e to the u plus c, and then we just go back. What was e or u equal to?
E sine
Sine t.
Wait, did the D, where did the U go?
It went with the integral. It went with the integral.
Oh, right, sorry.
Right. Again, you can easily check your answer by doing the derivative here. So if I were to do the derivative of e to the sine t, you would have to apply the chain rule. It would be e to the sine t times cosine of t. Isn't that what we started with?
Yes.
Yes. Okay. The next page just takes it one step further. So basically, it's going to be the same thing, but we have to basically figure out what c is equal to. We call this a particular solution. So on the previous page, if you recall, those were called the general solution. These are a particular solution, so it's an exact answer. In other words, we're going to figure out what c is equal to, and then we just plug it back in. Okay, so we have, start with dy dx. Oops. No, I paused it.
She can't have it on record that she stole the
What? It's not that I have a problem with it. It's just I don't want to have to like. Okay, thank you.
But Maya would want to hear.
You can explain to Maya why we paused it later. Okay.
Do we use u here?
No, we don't need u because it's not. Each of these can be integrated with one step. Like the integral of e to the x is e to the x. The integral here. Notice it's not like everything in parentheses is squared or something. You don't have like an inside and outside. You just have more than one term.
So 6x
Why do you do that?
Okay, so yeah, let's go ahead, integrate both sides. We get y equals e to the x. And then it's going to be what? Minus
Minus
6x cubed over 3 plus c.
Can you change it to 2x?
Yeah, we can change that to a 2x cubed. Now, the graph passes through the point 1, 0.
We put
So now
0
So we're going to use 1, 0 and solve for c. Okay, so that's what we're going to do here. So I have 0 equals e to the first minus 2 times 1 to the third plus c.
so
Okay, so c is some constant. So up until this point, some of you might have asked, like, well, what is this c? It's a constant. We just don't know what it is. We can figure out what it is if we have an x and a y value. So plugging this in, what do we have? Move everything to the other side. What do we have? 2 minus e is equal to c. I would prefer you to just leave it in exact form, not as a decimal approximation. So this would be 2, so I just moved it over. So c is equal to 2 minus e.
So we don't need to find the decimal approximation.
Nope. And then we go back. So then go back and plug c back in. Now that's why I said I really like these problems, because it's like if you just follow the steps, they're very straightforward. We just take this answer and we're going to plug it back in here. So it's y equals e to the x minus 2x to the third plus 2 minus e. So we're starting with the derivative. We find the antiderivative plus c. We plug our x and y in, figure out what c is, and then plug c back in. You want to try the next one?
can I say?
Wait, can you go back up for one? Yeah, there.
How about everybody try it on their own, and then
Then I can try.
This is you from the past.
Yeah.
Ben, whatever you're about to not study for, it's a bad idea. Study for it.
I don't even know. Okay.
But I'm not finished. Who cares?
Fight through the
I
video.
thought she was moving on. Hey guys.
I'm done.
And the numbers should work out nicely. I mean, even though you start with some pretty big exponents, I gave you numbers that are relatively easy to work with.
Really simple.
Alright,
If you got a really weird answer, then something went wrong.
I don't think I got this right.
Did we turn it on?
No, oh, I said at the beginning, that we're gonna do the notes first and then go over questions on the worksheet.
It's 5 minutes, 6 equals 5.
But it's
Okay.
not on the it's not on the
I didn't get a weird answer for
that
C,
might say plug
but
it
I,
on the third.
Okay,
it's not weird. It worked out nicely.
it's not weird.
Wait, can I help solve on it?
How about for this one, just give me,
Or,
help me out with the steps. So first thing,
the first thing we did, which we didn't show here, is we took the dx and times both sides by dx.
Okay.
The dx on opposite side.
so move the dx over,
Yeah.
and then step
And then
two.
we decide to integrate this problem.
Okay,
So the integral of dA is a, and the integral of the long thing on the right side is
So it's
x
gonna
to the
be-
10th, 10x over 10,
and then plus,
plus x to the 5th
good,
minus x squared plus 4x plus c.
okay, and then we're gonna take this and,
Plug 6 in for a, so you have 6 equals 1 plus 1 minus 1 plus 4 plus c. And so that equals 6 equals 5 plus c, so c equals
c equals,
1.
everybody else got one?
Yeah.
Good, so then go back and,
We plug that into
so x to the 10th plus x to the 5th minus x squared plus 4x plus 1. Questions? Not too bad, huh?
Is this considered hard?
I don't think so.
It should be.
I mean, it's calculus, so, I mean, I think on some level it's difficult. And of course, they can get a little, they do get a little more challenging.
Yeah, like Adam Ash should probably do this in his eyes.
Okay. I would rewrite this as x to the 1/2 and move the dx over.
We need a u here.
Do we need a u? No, we do not need a u.
We don't?
Nope.
No.
I'll show you why. So, what do we have? Y equals 5 tangent x. Remember, the derivative for tangent is secant squared. So the antiderivative of secant squared is tangent. What happens when we do minus 3/2 x to the 1/2? We get minus 3/2,
Over
3/2,
over 3/2. So,
and then what happens with the 3/2?
so they
Cancel. Good. So now we can go back to this condition, y equals 3 when x equals 0. So let's plug that in. So 3 equals 5 times the tangent of 0 minus 0 to the 3/2 plus c. Well, what's, yeah, what's tangent?
Understanding it just a little fast.
Oh,
No, tan of 0 is 0, yes.
yeah, tan of 0 is 0.
Why are we doubting wrong?
Rafi, why don't we call you Rashi?
So c is equal to just 3. Basically, these terms all go away. So now we just go back. We get 5 tangent of x minus x to the 3/2 plus 3. Are we okay with that one? Questions?
I think
Good.
I'm good.
Everybody else good?
Wait, thanks for kicking me. Got it. It's just, yeah.
Do we use you here?
God.
Why?
I really hope
Is
it's
the
paused
screen
right
cast
now.
paused?
I really hope it was paused.
Man, now this terrible thing.
So we integrate both sides.
Okay, so integrate both sides. What do we have? Y equals. What's the integral of cosine, guys?
Negative sign.
Plus c.
How come it's negative?
No, I'm sorry. No, it's positive, guys.
Oh, yeah.
Because the derivative of sine is cosine. So the antiderivative of cosine is sine.
There's a negative.
Oh,
No,
okay.
that's not a negative, it's equal.
That's an equal sign. It just, the lines got close
That's
there.
okay.
Okay, so now I have what? 1 equals sine of 0 plus c. What's sine of 0?
1, 0.
Wow.
Ew.
Yeah, sine of 0 is 0.
For example for A, can you go back up?
For a.
Yeah, oh, I forgot to write down the equation. So what are you, the equation is the antiderivative
And plus c. And then you plug in your point, and then you solve for c.
What are you talking about?
Wait, can you go up for a second, please?
I thought he was here the whole time. I was looking around and his thumb's not here.
Okay, are we ready? Okay, so next page are slope fields. Slope fields are basically just a series of segments that represent the slope at different points. And usually we have an x and a y value, not always. It could be just x or just y. The differential equation, so a differential equation is just another word for the derivative. So let's say we have dy dx is equal to x over y. So to create our slope field, you'll see there's a graph provided with 12 points, okay? And what we want to do is at each of these points, we're going to draw a small line segment that represents the slope at that location. Okay, so for example, let's just pick, let's go with 1. We'll start on the right corner. So 1, negative 1. So dy dx at 1 comma negative 1 would be what? Well, what would be the x over the y? 1 over negative 1, which would give us a slope of negative 1. Well, what does a line with a slope of negative 1 look like? It goes this way, right? It's kind of like whatever you go down to the left, you would go over to the right. So at this point, you want to make a line segment. Now imagine you're going to have a whole bunch of these line segments and you don't want them to cross. So make it, I'll kind of show you about that. So we go through the point, and it's approximation, okay? So a slope of negative 1 would be maybe like this, whereas a slope of negative 2 is going to get steeper. A slope of negative 1/2 would get more horizontal, right? Because like this is a slope of 0, this is an undefined slope. So you can kind of imagine that. Let's go to the next point. Let's go to 1, 0. Now, I'm gonna write out these first few, but quite honestly, I don't need you guys to show the work for all of this. You can use mental math to just figure out, you know, well, what's the y coordinate over the x coordinate. So what happens here? Ah, we get undefined. So in this case, just leave it blank. So we don't have to put a horizontal line here. If you did it, I wouldn't mark you down for that. Oh, did I say horizontal?
Yeah.
Yeah, vertical. Okay, next point. Let's look at 1, 1. So dy dx at 1, comma 1 is going to be 1. So it's going to basically look the opposite of the one below it. A slope of 1 again. What's dy dx at 1, 2?
1/2.
That's going to be 1/2. So what's going to happen with the slope field at this point over here? It's going to be just not quite as steep. Like that. Again, as long as I can see that it's not as steep as the one below it. Okay, let's see if we could do some of these without having to.
What's the point of like this?
Okay, so the point of the slope fields is when you create.
Sorry,
I have no idea. No.
I'd like to
I mean, that's in the
I'd like to give a shout out to Dom, who's gonna have to be watching this screen class after not having been to after class.
And we were just commenting on your absence from the class. Or I wasn't, but Andrew was.
You'll hear it when you listen to the screencast. You'll hear a lot of things when you listen to the screencast.
I would have looked
Okay. What's going to be the slope
1.
here?
It's gonna be 0.
What's the x coordinate? 0. So 0 over -1. So it's going to be a horizontal line here. What's going to happen at 0, 0? It's undefined, so we're going to leave it blank. How about at 0, 1?
Zero.
It's going to be 0.
At 2, 0, it's gonna be 0.
Good.
Good job, Andrew.
Okay, so since all the x coordinates are 0, of course, if that's in the numerator, we're going to get a slope of 0. What's going to happen here at -1, -1?
Negative 1, 1, 1.
It's going to be 1.
So you think it's gonna be the opposite of the other side?
Right, it's actually going to be parallel to this one. These two should look parallel to each other.
This one.
What's going to happen at
Blank.
-1?
-1.
0.
Negative.
Wait, right here?
No,
Oh, no. Undefined.
Oh, this one. Okay, that one's undefined. -1, 1 is going to be -1. And then this one's going to be -half. Good. Do you have your calculators?
Graphic design.
Do you
It
have your...
looks like a butterfly if you connect the dots.
Okay, do you have your calculators with you? If you do...
It's not working.
Uh-uh. You want to borrow mine?
Yeah, I can, I think.
Okay, on your calculator, there should be a program called Slope Field. Is it on your calculator?
Yeah, you get it.
I have a dumb calculator, so.
I transferred...
You probably get it.
Does it look like this? Press enter.
Wait, can you clarify? Program.
I think it's 5.
I have an egg.
The top left should be a -1/2. I transferred, when I transferred the programs onto your calculator, I transferred one that says Slope Field. Okay.
Yeah, Andrew didn't get the programs apparently.
Oh. So,
Okay, and put UIDX.
yeah, so you could do x divided by y. If you don't have it, I'll transfer it later. You could just kind of watch. So to get to y, you just use alpha y. And then you can go to, you could change the window if you want, or you could just go view slope field. And what it does is it creates, obviously, a
That's like the zoomed out.
it's a way to check your answer to see if you did the correct slope field, but it shows a lot more points, obviously.
Can you change
Um,
the win, like if we
you can-
changed it to negative?
This is
Right, so you could go back and change the window, so like number 3. It's only gonna let you like do in standard or zoomed in, so usually I would just do for like zoom in. And then resolution, I'll just do high. And then just go back to view the slope field number 4.
That's so cool. So what did you say? Please?
So like you could see where all the horizontal, can you see where all the horizontal line segments are along the y-axis, which makes sense because they had a slope of 0. And then here, remember how I said these are going to be parallel? Because they have a slope of 1. Can you see the ones that are parallel here? Okay. Just make sure, guys, once you're done, make sure you quit number 6, quit it properly, because otherwise it changes all the settings in your calculator.
they
Okay.
have on theirs, they have marks for on the x-axis.
Sometimes that's why I said it's okay if you put vertical lines, you don't have to. Okay, let's do this one, dy dx. What's going to happen? Let's go through these points. Let's start here at -1, 1. What happens if I have a slope field of x plus y? What's going to happen if I add -1 plus 1? It's going to be a slope of 0. So it's going to be a horizontal line. What happens here at 1, 0?
1.
It's going to have a slope of 1. And then at 1, 1, it's going to get steeper because that's going to become a slope of 2. And then a slope field of 1, 2 is going to be a slope of 3. So it just gets increasingly steeper, right? And then let's start like down here. This is going to have a slope field of -1. And then at 0, 0, it has a slope of 0. And then at 0, 1, 1. And at 0, 2, it's going to have a slope of 2. So these slope fields and differential equations actually go together. The next lesson that we'll do will have separating variables, and you have, basically you can take a slope field, you can graph the slope field, and then you can work backwards to find a particular solution. We did a little bit here, but we'll do more where we have variables on both sides in the next lesson. What do we have for our slope field for -1, -1? -2. And then this will be a slope field of -1. So, and this one, what happens here at -1, 1? This would be horizontal because it's 0. And then at -1, 2.
Bottom left one.
Where?
Bottom left.
This one?
Yeah.
Has a slope of -2.
Wait, can I share my idea?
Go ahead, share your idea.
Okay, so instead of having a final exam, we do other chapters.
We what?
We do another chapter instead of having a final exam.
That's not an option at this point.
But then we learn more.
You're gonna learn everything that we need to cover.
There's always more, right?